Hi students, this is the beginning of a series of videos looking at some deductive geometric proofs, looking at circles. And so this is our first video looking at proving chord theorems. Alright, so after watching this video, you should be able to prove that the chords of equal length on the same circle subtend equal angles at the center. Now, things to remember: the parts of a circle, so chords, lines that cut a circle into two pieces that do not have to go through the center. So a chord could be this line here that doesn't go through the center. It could be this little line here. But chords just cut a circle into two pieces. Now an angle is subtended by a line or arc when the angle is formed by drawing two line segments from each of the endpoints of the arc or line to a common point. So very wordy. But what does that look like? So let's say we've got our circle here, we've got our chord here, and then we're going to subtend an angle over here on the circumference. So this angle here we say is subtended by our chord here. Some other things you'll need to remember are the steps for geometric proof and also a bunch of our geometric reasoning statements and axioms and notation. Okay, so we've got to prove that the chords of equal length on the same circle subtend equal angles at the center. So looking at this diagram we've started here, we've got our two chords. We'll call those A, B, and C, D. What I'll also do is create those sectors by adding in these lines to go towards the center. To imagine that line straight, and we'll call the center O. Now what we've got to do then, right, we've got our chords, we have to prove that these angles subtended at the center are actually the same. So writing our statement, we're required to prove that angle AOB is equal to angle COD. Those green angles, they need to be equal. That's what we have to prove. So drawing our table together with our statements and our reasons, the first thing we can say is that AB and CD must be the same length. And we know that because we were given that piece of information in our statement, that the chords must be of equal length. So AB equals CD, and that information was given to us. Now the other thing we can say is that all of these lines we've used to subtend this angle at the center, they're actually all the same length because they are all radii of this circle, and the radius for a circle is always the same. So we can say that AO is equal to BO is equal to CO is equal to DO because they are all radii of the same circle. Looking at that now, looking at those triangles AOB and COD, we can now confidently say that they are congruent because we have three equal and congruent sides, right, shown in steps 1 and step 2. So triangle AOB is congruent to triangle COD. Now that we've proved congruence, we can say that corresponding angles are equal. The corresponding angles are AOB and COD. Those angles are equal because they correspond, and we've already proven congruency in line 3. So because those angles correspond, they must be equal, which is what we were required to prove QED. So students, just to review our learning goal, after watching this video you should be able to prove that the chords of equal length on the same circle subtend equal angles at the center.